Hi everyone. In this video we're going to be looking at how to add non-perpendicular vectors, which we already looked at in unit vector form, which is super easy. Here we just have a couple extra steps that we have to do. And we did this type of problem in honors physics. In order to add non-perpendicular vectors, we have to break them up into their x and y components. Right, so vector A is 5 units long, pointing at -30. So that vector would be somewhere down there. And the next one is 2 at 200. So if I make my axis, it's got to be a little bit more than 180. And 2 units down there. So we end up with a resultant vector that points in that direction right there. And that's what we're trying to find. The resultant of A plus B. Right? So in order to figure out the solution to this problem, we have to figure out the x component of A and add it to the x component of B. And then we have to find the y component of A and the y component of B. So if I was able to really pick up that vector and move it over and add those two together, and same thing here, to pick up that vector and add those two together, so it would look like this. So x component of A plus x component of B would give us a total x vector equal to that value. And then up and down, I'm going to start at the end of my second x vector, and I would go down for the y component of A, and then down a little bit more for the y component of B. So I have a net resultant there equal to that value. So if I just draw the sums, I would have the sum of the x's, which is the resultant x. I have the sum of the y's, which is the resultant y, and my resultant vector, if I drew that right, would be that point right there. But we'd also have to figure out that angle. Alright, so how do we do that? X components, as long as we're given the angle with respect to 0, which we were, we just have to use our x equation, which is ax is equal to a cosine of theta. Alright? So if we want to figure out the resultant x value, we have to add up the x components. We're going to add ax to bx, which is going to be a cosine theta plus b cosine theta, and then we can plug in our values, where it's going to be 5 times the cosine of -30 plus 2 times the cosine of 200. Now all you have to do is really just plug that right into your calculator. You don't have to do anything special. Just make sure you close the parentheses at the end of the angle input. And if we do that, we get 2.45. Now we do something very similar to the x, to the y, to find that value. So that's our x value. To find the y value, we have our y equation is ay is equal to a sine of theta. So to find the resultant y, we just add up ay plus by which is a times the sine of theta plus b times the sine of theta. Then we can plug in the values. It's going to look the same as the other, except sine is in place of cosine. Squeeze it in. And we get negative 3.18. Now that makes sense because on that diagram, these diagrams, both of those y components point down. So our resultant has to point down, our y has to be negative. All right, now to figure out the resultant value, we still have two more things we have to do. All right, so we have these two components here. We have x component to the right of 2.45. We have a y component down of negative 3.18. We're going to find the value of that resultant as well as the angle. To figure out the resultant, we're just going to have to Pythag the x and y components. When we do that, we get 4.01, which is just 4. All right, so now we have the resultant magnitude. So the length of this vector right here is 4 units. Now we have to figure out the direction. To do that, we are going to use our inverse tangent of the y value over the x value. And when we do that, we get negative 52.4. Now, is that the direction that this vector is pointing? Right. So measuring this way down from the 0 degrees, that gives us a negative angle. So the angle that we got right out of the calculator is going to be the correct angle. So our entire resultant is 4 units at negative 52.4 degrees. And that's how we add non-perpendicular vectors. If you have 3 vectors instead of 2, just when you sum up the x and y components, you're just going to have ax plus bx plus cx, and so on, no matter how many vectors you have. It's the same process all the time. All right? And that's all for this video.